Now we will talk about all the objects that can be invoked and how to do so. Also, we will talk about the invocation options available. For example, how to have the called object open with a certain effect and closed with a certain transition effect. We will see the invocation types that can be achieved, the size of the called object screen, and so on. All of this is known as CallOptions. First, we will review the syntax of invocations to work with components and panels, which are main objects with an interface in smart device applications. We had already seen that the work with list was invoked in this way, with the name of the work with devices of the corresponding object, the level name, and then the list method with no parameters. For the detail in view mode, we use the syntax that is displayed on the screen, where we need to send the primary key to identify whose detail we want to display. For the detail in edit mode, we need to indicate the mode. To insert, for example, a new speaker, if it belongs to the speaker transaction being used. To update a speaker's details, we need to send the primary key of that speaker. To delete a speaker, we also need to send the primary key. The insert operation was special. Remember that we may choose not to send any parameters, and in that case, the edit screen will be called, the user will enter all the details, and then he will save them. The other option, if we need to send the parameter to that detail screen, where the user will enter the details, involves initializing the values that we want to send in a business component corresponding to the transaction from which we want to call the work with. In this case, in the business component, we initialize the values we want to send to the object. Next, these values will be shown in the screen that is displayed, and the user will change the desired values and save. The business component will return as an in-out parameter loaded with the data entered by the user in that screen. For example, suppose that the business component's primary key is auto-numbered, and we need to know the value given to that primary key. In this case, we will use the business component to return that value. As we've seen in a previous example, we may want to know all the values that have been entered by the user. Okay, we also have the invocation to the panels, which is exactly the same as the invocation to any other GeneXus object. In addition to invoking the object, we can do so by previously setting, at runtime, the entry and exit transition for the user interface of the screen called. Note that effect is a predefined domain whose values are the transition effects supported by GeneXus. For example, in GeneXus, I'll show you how, in the dashboard, among the events, we program the call options, the entry and exit effect, for the invocation to the speaker work with the list. Remember that we had done this before in a static manner at the form level of the object that was opened. We did this in the form class, setting the effects, but we can also do it in this dynamic manner. If we open the emulator, we can see that the opening transition effect appears from below. When it's closed, it moves in the opposite direction, push up, push down. Here we have the effect predefined domain, which can be seen if we open the domains. View domain. We select effect, which is a predefined domain set to read only and has the values supported by the tool. We can also indicate the object's behavior according to the type of call. For example, if we want the called object to open as a pop-up window. Note that in this case we have the call type predefined domain, which will take one of the four values displayed: push, replace, pop-up, or callout. In a few minutes, we will see an example of these cases and study them a bit closer. We can indicate the size of the screen where the called object will be opened, and the region, target, that the called object will take. This is why before invoking the object, we need to define the desired call options, which can be one or more. Remember that the right regions are available for slide navigation and bottom in iOS, as we saw when we studied the application's navigation style. The navigation external object that we mentioned at that time allows developers to dynamically show or hide contents in the desired region. For example, if the app's navigation style is slide and the central panel contains an event defined as shown, the panel not only has to be loaded in the region to the right with the target call option that we're viewing, but it also has to be displayed. To do so, the showTarget method of the navigation external object is used. The type of invocation, callType, defines what will happen with the invocation stack, as well as the way and mode of the window in which the called option will be opened. The first two types presented, push and replace, define what will happen with the invocation stack when the call is made, which will be related to the object it returns to when the call is finished or when back is selected. The last two types, popup and callout, will define if the invoked object will work as a popup or as a callout window. In addition, for a popup window, the screen will be modal depending on whether or not parameters are returned. For the callout type, it will be non-modal. Tapping outside the callout area, that is to say, outside the little screen, enables the caller. It's precisely for popup or callout types that the other call option appears, target size, to indicate the size of the popup or callout screen. As for push and replace types, push is the default type of all invocations. That is to say, even if we don't set any type, it will be opened as push. Suppose that an object X called an object A. If now from A, in an event, we call an object B with the push call type, the called object is placed on top of the stack. Its screen is opened above the caller's screen, taking exactly the same place. To continue running, the caller waits until the called object B finishes running, which is then removed from the stack. Next, the following command, which came after the call to object B, is executed. On the other hand, if from object A we call object B with the replace call type, the called object will also be opened exactly in the same screen area as the caller, but will replace the caller object in the stack. Therefore, when it finishes running, it will not continue to run A's event. Instead, it will return to the object placed before in the stack, which in this case is object X. Therefore, what came after in the event will obviously not be executed. Regarding popup and callout, let's see the popup type. If the target size is not changed, it will take the same screen area as the caller. Otherwise, it will take the area configured in target size. If one of the invocation parameters is an output parameter, the dialog will be modal. That is to say, the caller will wait for the return of B's execution to continue. If none of the parameters is an output parameter, the dialog will be non-modal. Let's see an example that we had already used. When the user selects the list of restaurants, with the Map button, we want to give him the option to see them in a map. But before showing them, we want to let him select only those restaurants that commit to providing the service within the maximum time frame he has available. Note that the first screen is the list node of Work With Restaurants. The second one is a panel, which we've already seen, called Restaurant Filter. And the third one is a panel called Restaurants Map, whose layout is almost identical to that of the restaurant list, except that the corresponding grid will have the control type properties set to SD maps. In addition, this grid's conditions filter by the time the customer has available for lunch, and this time is received in a parameter. We want the restaurant filter screen, which we're seeing here, not to open in a new screen, taking all the screen area. Instead, we want it to open as a pop-up. As we can see here, it's a modal because this panel will be called for the user to select a value. When the user clicks OK, it will return this value to the caller. Also, we want it to take a smaller screen area, a small area. So, before invoking this panel, restaurant filter, to which we send the timing and the OK variable, which are two variables that will be returned by this panel, we configure the call options. type as Popup, and target size as small. Let's see it in GeneXus. In the restaurant work with, at the list level, we have the map button. We see how its event is configured, and that we had commented on this. We remove the comment, and we see that the call type domain is also an enumerated, predefined domain. Which takes the values popup, replace, push, and callout as we had mentioned. Alright, what it does is configure these two invocation types and then call the restaurant filter object, sending it both variables. So, if we see it in the device before generating the application, let's see how it worked when these two call options were commented. We called the list of restaurants and selected the map option. This panel is displayed in full screen view as any ordinary invocation. Here, we selected the value we wanted, for example, 90 minutes, and after clicking OK, another panel was displayed with the restaurants shown on the map. Now we will build the application. My phone is not connected to the internet, but if it were connected, the live editing feature would automatically show the change we've made, which was to remove the comment from the CallOptions commands. So, now I will plug it in and show this running. We select Run. The application is opened. We do the same again, Map, and as we can see, it's displayed as a pop-up, and it takes this screen area. The rest looks the same. Alright, we can also set the size of the callout or pop-up window in dip or percentages relative to its parent. This is the end of the topic related to behavior, which was our objective. We've seen how to design the application and how to program its behavior. Let's move on to the next topic,